Welcome to What's New in Sheet Metal. This is the fourth video in this series, and as I've stated before, I have taken a 12-month vacation from Fusion 360, and this is the time to catch up on all the great stuff the development team have been working on, but we're going to slow down, we're going to take it step by step, we're going to make sure that no man or woman is left behind. So with that, bend, flat, go. Hello everyone, my name is Lars Christensen and thank you so much for taking the time to watch this video. This is where we're going to catch up on all the what's new in Fusion 360 over the last 12 months. Because let's be honest, unless that you are a power user, you maybe have missed some of these, or maybe you're wondering why you would use some of the different options. So, give it a thumbs up if you like the video, give it a thumbs down if you don't, leave me a comment. I'm back. And also down in the description area, I have left a way that you and I can connect via email. So with that, let's get into Fusion 360. All right, so first thing we're going to look at here, I have this little sheet metal bracket here. This is a bracket for when you're hanging your blinds in front of your windows. Then there's kind of two brackets of these sitting on each side holding the blind in place. And this here is actually an imported model, and you can see that, a couple of reasons you can see this. First of all, this is a imported step file. You will see that there's two bodies over here. And if we go in and look at this first body, you will see that there's no sketches or anything in here. So it's what we call a dumb solid. You will also see that I don't have my history turned on in here. Whenever you are bringing in like a step file or another type of file into Fusion, it ends up in what we call direct editing mode. But what is new in Fusion with sheet metal is that you can convert these, what I call dumb solids, a step file or a SolidWorks file or a Inventor file, into a actually sheet metal part right inside of Fusion. So if we go over to the sheet metal tab, you will see there's an icon up here that say convert to sheet metal. And if I click on that, it will tell me that it's going to turn the history tree on. So we can enable design history. And you will see that that's now activated down in the bottom. And then all I have to do is select one of the components or one of the sides, faces of one of these bodies. So I'm selecting on this side what belongs to the body over here. And then it will call up your sheet metal rule set for whatever you had. And if you're not familiar with sheet metal, like in Fusion, you can totally customize these sheet metal rule sets. So I'm just going to pick the default I have in here. And you will see that I've detected that this is 1 millimeter thick. So this is a tiny little bracket. So I'm going to hit OK to that. When I do that, you will see that it converts it from a body into a sheet metal part. So if I just expand it here, you will now see that it has the rule in here and it has a sheet metal body. We can do the same thing with the door piece here. So now you will see the icons have changed a little bit, but that's because now it's kind of like, because we now have a sheet metal part, it's ready to go, but the convert is still sitting right down here under create. Click on that, click on the door part here, use the same template and hit OK. And now we have two sheet metal parts. That means that now we can just activate which one we want. And then we can go ahead and create a flat pattern from it. So when you do that, you got to select what is the stationary face. Select this bottom part of this bracket, hit OK, and then you will see that now it becomes a flat pattern. So you can now use that for cutting out with a water jet or a laser or whatever you want. We can do the same thing with the door. We can go down, we can activate the door. And we can go over and say we want to do a flat pattern. Maybe we select that back face there, hit OK, and that will then become, get that flat pattern there. Now, as you maybe have already noticed, we actually kind of like have a sheet metal assembly. So just in case you didn't know, if you are already working with sheet metals, this is probably not new to you. But we can actually use our standard assembly tools inside of something like this. So I can right-click on the main body, and I can ground it. So now that is kind of grounded and stuck in space. And then one of my favorite assembly tools is the as-built joint, because this door is sitting where I kind of want it, I can just go ahead and click the two components, and then I can place, I have a revolute here, I can place that wherever I think I want it in here. Let me just zoom in, let's click it right there, and then we have a revolute joint placed, and now this is working as an assembly. So that is one of the new things inside of Fusion here, converting dumb solids or imported models into sheet metal. Now this part here, to show you the next what's new, I thought that it would be a good exercise and some best practices, because I have a tendency to make these a little long, to go ahead and actually let's do this part from scratch in sheet metal inside of Fusion, and then we can kind of talk and we can do some tips and tricks in here. I want to show you something about how we can do some of the different bends. You will see there's like a little dimple in here. I'll show you how I cheat to get those in there. Some tips and tricks with the holes. So let's do that. So I'm going to go ahead here and I'm going to open up. Let's leave this one for reference. I'm going to open up a new document in here. And again, we're in the design workspace, and we can go over to the sheet metal tool over here. And because we know that this is now going to be an assembly, we know there's going to be multiple components in there, we can do this, what many people know as a rule 1 in the forum, as we're doing with assemblies. Before we do anything, we kind of create the components that we want within the assemblies. It's just a good practice. So I'm going to go ahead and say new component, and it's going to give us a something here. We can call this, I called it before, could call it the body, but let's call it the bracket instead, just so we distinguish the two. I'm using my steel rules. I set the thickness to 1 millimeter, and I also have a bend radius here of 0.25 millimeters that I've adjusted in there, just in case you want to go in and work with your own with that. So I'm going to hit OK to that, and that's going to give me bracket number 1. Now I'm going to go up and activate my component again, and I'm going to do another one up here, and I'm going to call this one door. Okay, use the same sheet metal rule set. So now we kind of have these two brackets in here, and you just activate which one you want to model it. And this takes a little practice, and sometimes, it takes a little to get used to. But let's go in and model this up. Now, one thing I want to point out, like again, I know if you are a sheet metal expert, this is probably way above, then you probably don't need to watch this video. But what I've seen many people do when they start doing sheet metal parts is that they go in and they just create a sketch. And you maybe have seen me do it too, because I'm sometimes. So let's create like some kind of a sketch here. You finish it up, so now you got a rectangle, and you fully define it, and then you go ahead and you hit the flange tool. The magic tool in sheet metal is the flange tool. And then you hit OK, and then you kind of got your basic shape here, and then you can start adding more flanges and start building up like this. But what I want to show you is, don't forget that inside of Fusion sheet metal, let me just delete all these again. Sketches is actually more powerful. So I can actually go in here, create a sketch. I'm going to do it on the side view here. And I'm just going to go ahead and create a line. And I'm going to go over and then go up a little bit like this, and go over like this. So I kind of created a line like this. And then you can go in and hit D for dimension. Let's fully define this one. So I'm going to make this one 30. I'm going to make this one 2 millimeters. And let's make this one, I don't know, 6 maybe, like that. So we have like a little line segment going like this. And if you're, sometimes I like to do a little like that. Okay, so a line going over there, up and over. Okay, what I want to show you is that when you're working in here, the flange tool will work with these. So I can actually start on the flange tool right here. I'm going to go symmetrical, and I can get my first bends in. I'm going to go 15. I can get my first bend in here, right out of the gate. So that's kind of just an interesting way to think about this. Instead of doing the square and then do a flange up and a flange over, you can actually start out by maybe just getting something like this into place. And at any time in the process, if I just expand out the bracket here, you will now see that we have one sketch and we have one sheet metal body in here, nothing too fancy. But at any time, you can go ahead and you can create a flat pattern from that, and you can see it flat with the bend lines on there. Get out of that, and then you have that flat pattern in there to work with. All right, so let's go ahead and just start creating our part here. So I'm going to go ahead and go up here, and I am going to go 30 millimeters up, go out here too. I'm actually going to go over like to the outside of this, like this. And then one trick I want to show you that is new. Now you will see you get a warning with the flat pattern because I added a new flange, but you can always right click and just update the flat pattern, and then it has taken that into calculation. So now if I right click and I said activate, then you will see we now got our second section over here. I maybe get a little bit too basic, but what is new in Fusion is that if I go ahead and activate a flange and I select this one here, I'm going to select this one on the inside here. I can start, see here how I can start making the side. You can actually select multiple side within one operation if they go to the same height. So I select the first one. You can actually go over here now and hit add two, and then I can select that other side, and just like that, I can add two sides that does the same thing within one command. I'll show you that. So I got that there. We could, for example, there's like a wraparound on this side here. So I'm going to go ahead and hit the flange again. I can select this side. I can select this side. So two edges, and then I can go to, I'm going to go adjacent here, and then you will see that I can actually create two sides at once. So what is super helpful about this is that we are kind of working with less operations, right? We get less of these flanges down here. What can be helpful. All right. So that is the second thing that is what is new, and that is actually all I have. So converting a solid into a sheet metal, and then that you can now multi-select in there. I don't think I'm forgetting anything else. All right, let's keep working on this one because I think I'm going to show you some things that you hopefully enjoy. So another trick with this flange tool is that if I select this edge here and pull an edge out here, you can grab this little handle and you can move it over. Now when I move it over, you will see that it interferes with our already flange, and you get a warning about it down here. It's not an error, it's a warning. But what you can actually do over here in the flange command is that you see that it says full edge. If I hit the drop down, I can say 2 offsets, and that will give me an arrow here and an arrow here. Now I can actually just drag an edge up like this, and I can add in -3 millimeters maybe. And I have now moved that edge up, and now I don't have an arrow anymore. I'm actually going to go in and edit that feature and grab this edge because I want to control the depth of this. And one of the things that is nice when you're working in sheet metal is you can actually I can even control, if this is active, so if I pull it, so you see it's blue, if I select this little snap point here, you'll see that it connects to that edge. So that is super helpful. I'll show you that little trick again because I want the same thing on the other side, just a little different. So I'm going to go ahead and do another flange here. Pull this out. I just drag it out, rotate it. Now we're going to get our warning that we are actually colliding with our part. I'm going to switch this to a 2 offset. I'm going to do the same thing I did before. I'm going to move this one up about -3. Like that, so it's the same height. But what I want to change is, instead of doing that to that intersection point right there. I can also just select on that face right there. Hit OK. And then we kind of got that laid out right there. Now at any point, again, like I said earlier, you have this flat pattern here. You can right click, you can activate that, and you can go ahead and see what you have created in here. So you kind of can go back and forth, All right. So we're still working just on the bracket here. And many times when I'm talking about modeling standardly, I'm talking about adding your fillets and your chamfers on here in the end. And that's kind of probably also somewhat the best practice when you're working in here. So we're just gonna leave that for right now. But one thing I wanted to show you is how we can work with we kind of got the base shape together here. One of the things we need to do is we need to punch some holes in this. And as this is folded here, you can actually go ahead and just open a sketch on a face like here. And it acts the same way as if it was a standard body you're working with. So if I go ahead here and I make a hole here that is 10 millimeters in diameter, I can go ahead and I can do a D4 dimension and I can place it. Let's do this 15 and let's do from here to, I like the edge. So this edge, and do that 15 also. So it's kind of in the center. So that's a standard kind of sketch, and you will see that that gets placed down here. We can go ahead now and do a extrude, or press pull, same thing. Drag it through here. Now, I will normally, when I'm working with something like this, I would normally not just drag it like this and leave it. It's just, if you're changing things, if let's say we made this narrower, suddenly we will have that 10 millimeter hole going all the way through. So one way you can do it, you could do, just click on this back face here, and then it will use that measurement right there. So we get a cut there. So that's one way we can do it. The whole thing is folded up. And actually, I have a smaller hole over here on this side. So what I'm going to do is I'm going to open a sketch over on this face. And then I can use the center of this hole. So if I do P for project, just like you've seen me do in the modeling environment, we can do that. Hit C for circle. And now we're using that center point of the 15 and making sure that this 5 millimeter hole sitting over here, and we can now go ahead and use cut through that, right? That way, and click there. Now I know that if I ever need to change the hole location for this hole, all I have to do is to go over, right click, hit edit sketch, and if I change, this dimension to 10, like this, you know that our other hole will follow along. So you kind of have these different options in here. Another option we have when we're working in here is we can actually also do these in a flat state, because when you're working in the tool and die, when you're actually punching these holes, you're doing everything when it's flat, not when it's all folded up like this. So there is a function in here under modify that is called unfold. You click on that, and it asks for, again, a stationary entity. So it's kind of like when we did the flat patterns. I'm going to select the bottom. And there you can select your bends. You can actually just go ahead here and hit unfold all bends, if you're lazy like I am, and hit OK. And now you will see that you have kind of created a flat pattern. But it's a flat pattern that lives in history, what you will see in just in a second. So it kind of lives within your history tree out here. You can go back and forth. So there's a couple of different ways I want to show you how we could place some holes. Now, one way to do this could be to start a new sketch on kind of like this face, or this face, doesn't really matter. Select on this face, and you could do something like and hit O for offset. And if I select here, I can kind of like drag in, if it was like in the center, -6. And I could use this to place some holes. And the way you could do that quickly would actually be, if I exit out of the sketch, is to go in and find the hole command, because that also lives within the sheet metal. You can select the holes, you can select placement, you can select multiple from a sketch. If you have a sketch, and we do that, you could go ahead here and you could just click on these 4 things. We could go in here and say we want 5 millimeter holes, go all the way through, hit OK, and we have now placed these holes. What is kind of cool. And that works. If I go ahead now and I say, let's refold the part, you will see that the part is folded up with these holes. But another thing, and now we actually have a unfold and a fold over here. And this works down in timeline. So if I go one back, it's flat again. But I wanted to show you another way you can do this, because I think that there's many different ways to place holes, and I just wanted to show this. So if I go ahead here, I just deleted the sketch and the hole command. If I go ahead here and open another sketch on that same face, you could draw a line and make that a kind of a construction. You can do that by selecting the line and hit X, so now that is construction. I would still maybe use if I'm placing 4 holes as I'm on this part, I might just sketch up a rectangle also. And you could now use my favorite command, which is the symmetry command. And that would be 1 point, 2 point line. So now this is these are symmetric. So if I drag one corner, see how it's symmetric over our line here. And now we could hit D for dimension. We could place some dimensions. So I'm going to select the edge of our fold here. And maybe I make that 6. And then I could place a dimension from here. Let's make this 15. Let's make this 15. So I'm kind of sketching the same thing as we did before, right? And if you want to select that whole rectangle, here's a neat little trick. If you double click on a line, then it'll select the whole thing. Hit X to make it construction. These shortcuts. And then I could hit C for circle. And I'm just going to draw these circles up here. Again, I'm just kind of showing you a couple of different ways you can do this. And then D for dimension. So I've just placed 4 circles. That is wacky. I didn't try to get them accurate. And let's make this one 5 millimeters. You can see that it's black. It's fully defined. And then we can use the equal command and just go around here and do all these to be equal to one another like that. And that is fully defined. And then we could now go in and create our extrude and cut these holes out. That's one way we could do this. I finished up that sketch. But the reason I wanted to show you this is if I go back into the sketch here, edit sketch, you could actually go in and do a little drag a window around here and select all our geometry. And then we could do a Control C, what is copy, finish that sketch. We could go up and open a new sketch on this face and do a Control V. So again, that's kind of like Windows commands. And that will open up the move copy. And we can now move these holes up here. And now we have these holes up here. Now you can see that they're not fully defined. They're not all black because they are now moving around like this. So we could go ahead and create a line from our origin again, just to have a construction line here. Hit X to make it that. Use again the symmetry command from here to here to here. That will make that concentric. And then I think it was 6 millimeters I did on the first one, from the edge to this edge. Make that 6. And then I have copied one or the other within this. So what is really left at this point is maybe going into extrude, we can select all our holes like this and cut them through to the back side here, and then we placed these holes here. And now if I move to after the fold, then you will see that we got these in here. So a couple of different ways to kind of achieve the same thing if you wanted to use the hole tool, or if you kind of like want to work it up with the sketches. I wanted to show you how you can Control-C, Control-V sketches in case you had not tried that. That is one of those interesting functions. All right, the next trick I want to show you, I'm gonna wrap this up. The next thing I want to show you here is I put in kind of a dimple on the back, and here we are gonna kind of jump back into the solid workspace where you normally are working instead of the sheet metal. But I want to show you how you can go ahead and do this. So what I'm going to do is I'm actually going to create a standard solid body. So I'm going to go back into my solid workspace. You can jump back and forth here. You don't have to do all in one. I'm going to open a new sketch. I'm going to select the side view because I'm going to use the revolve function for this. And I'm actually going to hit P for project. I'm just going to grab this back edge here. And when I've done that, I really don't need my sheet metal bodies. I'm just going to hide it for a second. I'm going to create a line. I'm going to find the midpoint of my projected edge here. I'm just going to go back. This really doesn't matter. Go up a little bit. And then I'm going to go back here to make sure it's horizontal. Go back here and snap it into to a part here. So I kind of have this rectangle here. Now I know that this part is going, the thickness of my part here is 1 millimeter thick. So what I'm going to do is I'm going to create what am I going to do? I'm going to create a line in here, and I'm going to make that line 0.5 millimeter deep, I think. And then I'm going to make a line vertical up like this. Okay, so I got that. And then I think I'm going to go in and create a 3-point arc and just place an arc here like that. And then if I use the tangency tool between that arc and this projected line, then I actually get this here. And I also want this to be tangent. So I'm going to make a little helping line here. I'm going to make that construction and make a tangency between here and here. So now I kind of got this little thing here. Let's go ahead and add a dimension here. Let's make it 5 like this. So now it's fully defined. So notice how it's straight line. It goes 0.5 millimeter into our sheet metal part. If I turn the sheet metal part on, we can kind of see it there. Sticks halfway in there, it goes around. It might be a little too big, but I don't think that will work. I'm going to hide the body again. Now if I didn't put a length in here. Somebody will tell me that's a bad idea. Make that 30. Now it's fully defined. Now I can go in and use the standard revolve feature inside of Fusion. So I'm going to go in and select my profile and the axis to revolve around and hit OK. Now I kind of ended up with a kind of a stamping tool. Actually, we probably also want a little bit of a fill it on here. We could add that now, I guess. Go in and add that. I could also have done that in the sketch. That doesn't really matter. Now, if I turn my solid body or my sheet metal body on again, you can see that these two are now intersecting. Let's go in and do a section analysis. Select this top face. So you can kind of see now how I have buried that. I buried that inside of there. So turn the section analysis, cancel the section analysis. So what I can do, and this is standard for in the modeling workspace, I can use this combine tool, And I can go ahead and I can say what is my target body? That is our sheet metal part. What is my tool body? That is that stamp I just created. And I am going to cut. But what I'm going to do is I'm going to say keep this tool body, what means this thing's not going to go away. If I don't check this, this will just be gone. But if I say keep the tool body, hit OK, then, well, it looks like nothing happened. But if I hide my body, you will see that I got the dimple impression in one side, but I didn't get it on the other side. And this is where I'm kind of like, I'm cheating a little bit here. This is a little bit of me just cheating. So what I'm going to do is I'm going to turn this body back on that we had. And I'm actually going to go up to the top view. I'm actually going to go in to the move copy tool. I'm going to select that cylinder, and you see here it is. And I'm going to move it in 1 millimeter, minus 1 millimeter, right there. And I'm going to hit OK. So that body still exists. Now, right now, we still have the dimple. If I turn the body back on, I've now moved this in so it sits here. And here is where things, I think, gets kind of interesting. If I hide my sheet metal part again, I can use this. Many people are asking about what's the difference between extrude and press pull. The neat thing about press pull is press pull does the same thing as extrude, but it actually also can do other things. You can go in here, you can select an edge, and you could actually now put a fillet on it. I could use that instead of the fillet tool. But what you can also do is, if I hit press pull here, and I just drag, I'm almost cutting away my little stamp here, all the way back to my -30. So I'm literally removing the whole straight portion I had. And if I turn my sheet metal body back again, now it looks like I have that dimple. And all I now have to do is use the combine tool. Instead of cutting, I'm going to join this with that body like that. And now that has now, oh, and I had the tool body on. Hang on. Edit. Turn off keep tool body, because now I don't care about that tool anymore. Hit OK, and you will see that the body goes away, and now I have created this dimple. And this is all captured down here in this little workflow down here. If I go up and I say that I want to activate my flat pattern, you will see that it becomes flat, and the dimple still shows on like it had existed in there, like I've been put in that way. So that's the trick to show something like that. And I know that this is probably going to be a long video. And another trick, just to show you, we can actually go in here down in our history tree. You can do this in any workspace. We can go in, we can hold down Control, and we can select multiple operations. You can right click, and you can create a group out of it. So what this will let me do, when I create so I just down in this history tree, you can do this with anything down here. I can just select here. I can also hit Shift and select the bottom one, selects all these. I can right click and say create a group, and these are now grouped together. If I right click on that group, I can rename it, and I can call this my dimple tool. And now, 6 years from now, when you're opening this pot up and you're wondering, what the heck, that was all the tools you used to do that dimple, what was kind of like a workaround kind of thing that you maybe want to not, it's almost like an operation within an operation, right? So now you're kind of hiding that in there from that. You can do the same thing with the holes. If you think that these holes should have been, grouped together as holes. So this is one of the ways you can you can expand them. This is kind of a way you can work with that timeline. All right. I am going to add a couple of chamfers to these edges here, because now I'm just about done with this part. Oh, Let's go 3 in like this. And that almost finishes this part. We need to put a hole here for the hinge. But let's just flat pattern this, activate. So you can see the flat pattern, we're still good. Like that. Let's create that last hole here. So I'm gonna go ahead here and select the sketch on there. This is gonna be a standard sketch, right? C for circle, 3 millimeters, D for dimension. Let's go ahead here and maybe do it 3 inches from there. And 3.5 there. Hit Q for press pull, and we can cut that there. I still don't use the hole command, even though that maybe I should. That's gonna finish our one bracket here. So now we could right click and we could get this turned out to send that out to the laser cutter or what we need. So let's finish up the doll. Now the doll, I'm going to minimize this. The doll, we just created the part, but we don't have anything in here other than the rule. So what I'm going to do there is I am going to activate the doll, and I'm actually going to use, so now we can see how everything gets transparent. I'm actually going to go ahead and I'm going to create a new sketch. I'm going to use the center plane here so we have symmetry. But I think that I'm going to borrow this edge. So I'm going to hit P for project. I'm going to borrow the edge from our brackets, right? So I'm borrowing that. I'm going to hit L for line. And I'm going to draw a line that's going to go vertically up to about here. And then I'm going to use my coincident for that line to that edge of our bracket. So the doll right now, as I'm working on this, is referencing the bracket. So I'm utilizing what I've already drawn up in the bracket. Now, but I have the doll activated on that little thing there. So now I can go back to sheet metal. I can say I want to do a flange. I'm going to select that line. I'll select that line. And now you will see that I'm getting kind of like a flange out here. Now I'm going to go in 2 directions, 2 sides. So the first side here, I'm just going to go up to that face. See, I can also select the face of our brackets. I'm using that same one. This other one, I'm actually going to stay a little shy of that edge. So I'm only going to go 10 millimeters. I'm going to keep it 5 millimeters short. But again, this is pretty cool inside of sheet metal. I can actually go ahead here and hit the extrude, and I can just extrude this face out, and I want that to be equal to the face on the bracket there. So that gets the other 5 millimeters. And then I need to wrap around the edge, and we were kind of like already seen how that works. So we can kind of wrap that around that. So let's make that maybe 5, like that there. And this is a sheet metal part by itself. Now it's not, we haven't flattened it yet, so we don't have a flat pattern. But again, you can do this at any time, but it's kind of nice that you can click on something and make it a flat pattern. Now we get to see it, be like, okay, that's something we can flatten out, and you can go back again, you can see it there. I still have the dough active, and now I'm just gonna go ahead and say I wanna create a sketch, and I wanna create a sketch on this face. Hit P for project, select this projected line, and then I can do a Q, standard press pull. I can pull that through there, and now I have that in there. Last thing I need to do I think, to this part is put some fillets on it, because I actually think maybe I shouldn't have made it all the way over to the edge. Let's put a round on here. There you go, a full round on there. But I think I'm going to hit when I start spinning that around. Well, let's try it. So this is now done. That means if I go up and I turn my assembly back on, this is now kind of the same thing as we had before. I have to adjust a couple of things. So I'm now going to go in and do what I did with the imported model. I'm going to right click and I'm going to ground the bracket. I'm going to go over here and I'm going to, now this door can move around, right? But the bracket cannot move around. So now I can go in and use the as-built joint. Select these two. Still remembers I want to revolute. Place that. Zoom in right there. Hit OK. And let's see if we start opening this one here. There's definitely some collision right there. That is not ideal. So let's go down and activate the door. We can go back and find out what extrusion. What extrusion was that? That was probably that one. Edit. Nope, that was the hole. Was this one? Edit. Yep, that was 5. So I'll make it 4. Get out of that. And now that doesn't hit, but it does hit up here. So let's make the bracket active. And then we could add a fillet on this edge. I want to make that one 2.5 maybe. If that's enough. And that, whoops. Did that clear it? I think it did. So now we got that. So, and that should close up then. You can always use these, revert back to position. And we can kind of see how the bracket is all showed up this way. So when we have this one active here, we see everything that we did all together. If we go down to the bracket, you will see all the different steps we did for the bracket. We go down to the door, and we will see the steps we did for the door. All right, folks, I hope this was useful. You let me know. You let me know in the comments, please. So the things to show was that we can convert a step or a SolidWorks or an Inventor file into a sheet metal part, which is super awesome. But then also how we can select multiple edges, like we did there in the beginning, and we can drag 2 sides up. We can have multiple sides, multiple flanges being created. I am also going to leave a link to a video I did a while back about how you can test and figure out when you are flattening out something, how much you should put in those sheet metal rules. Some places, some shops, it's like a rule of thumb that people are using, and I'm sure somebody comments down. If you're a sheet metal guy, comment down in the comments area. Many places they have rules of thumbs of how much to your K factor or whatever you're using bend radius is. But I made a video on how to figure that out if you don't know where to start. So you can do some testing. You can find out. That is really depending on the material. It depends on what machines you're using and things like that. So I hope this was useful. A little long, but I kind of like to throw some of these tips and tricks and hopefully inspire somebody to do something. Send me an email down in the description. You can find my email address and show me some of the cool things you're doing with sheet metal. Love to see it. Hope this was useful. Until the next time, I hope you have an awesome, awesome day. Take care, folks.